Okay,
Okay,
so
so
I think
I think
time to
time to
start.
start.
Tim, could you
Tim, could
start
you
your
start
first
your first
presentation?
presentation? Thank you.
Yeah, we have
Yeah, we
our
have
first
our first
speaker, Tim.
speaker, Tim.
The paper
The
is on
paper
the
is on
value
the
of
value of
oversampling for
oversampling
deep
for
learning
deep
software
learning
defect
software defect
prediction.
prediction. Okay, thanks for the introduction. Sorry for the full screen. Somehow I cannot find single screen in this interface. My apologies. My student, Rahul Yeti from NC State University, came to me and said, I'm very worried about deep learning and software engineering. I said, why are you worried? He said, I've just done a literature review on defect prediction and software engineering, and most people do not compare their methods with non-deep learning, and most people don't do hyperparameter tuning, and most people don't do oversampling of the data. And I say, why do you need to do oversampling with data with deep learning? The first few layers of deep learning automate all the feature engineering. That is what all the press says. He says, yes, I tried that. I have data sets where the defects have very changeable frequencies in the training set and the test set. Sometimes a lot, sometimes not much. These are large Java systems. And when I run these with a standard deep learner, what I find is when the training and test set have about the same frequencies of defects, everything's good. These blue dots are F1 measures, recall precision up 0.8, 1.0. But when in the training and test set there is imbalance, deep learning goes terribly wrong. Some of these results are absolutely terrible. I said, what can you do about that? How can we make deep learning do better? He said, I think what is wrong is deep learning is we are letting deep learning do too much. We must do better than what deep learning does. The real problem is not deep learning. It's not support vector machines. It's not algorithm. It's what is the data. The data has hyperspace boundaries, hyperspace boundaries, and sometimes hyperspace boundaries are very good. This hyperspace boundary here isolates the orange examples, but sometimes hyperspace boundaries are very bad. These blue examples are spilling out across too many things. Ideally, we want hyperspace boundaries that divide the examples. And I said, we have those. We have already tools called support vector machines to let you tune parameters to give you good hyperspace boundaries. He said, yes, but there's a problem with those methods. I said, what is wrong with the way we're doing hyperspace boundary engineering? He said, it is global decisions that hold across the whole data. And I said, what's wrong with that? He said, the opposite to global is local. And what he wants to suggest to us is we should do local re-engineering of the boundaries between examples based on local information. For example, if we have a minority class and a majority class, he proposes a weighted loss function where the loss functions are treated separately for minority and majority classes. Also, Rahul has these methods. This is something he likes here called fuzzy oversampling, where you go to all members of the minority class, and for radiuses around it with decreasing probability, you add in artificial examples. And what that does, in a sense, is it builds a hill around a local example, pushing away the hyperspace boundary. And I said, well, does it work? He said, yes, I did. Here is an ablation study. He's recommending this method down here that gets F1 scores of 80% with IQRs of 25%. And IQR is 75th minus 25th, non-parametric variance. And if we look at this, you can see there's a group here of methods that do very well. Performance drops, and then there's another performance drops here. Here are the methods that you would use if you used off-the-shelf deep learning, listening to the current literature. This deep learning, oversampling, and SMOTE, and these all perform very badly. Only when you add this performance bump here, why don't you start tuning all these methods? So he tunes with differential evolution. The next big performance bump comes here. You see these double 2 ticks here? Rahul reckons all his methods here add in so many other examples. You have to do fuzzy oversampling, not just for the minority class, which is 1 tick here, but here also for the majority class. So it's really good to go to both the minority and majority class, add in artificial examples in the local region, and push the hyperspace boundary away. I said to Rahul, what is the lesson of this? He said, well, we should stop using deep learning uncritically. We should stop using it off the shelf. We should think about very carefully what we're doing and make better adjustments. Further, he has now, not just this paper, but after this, he's got 4 or 5 different localized hyperspace boundary operators who are writing up right now. And we think the future of software analytics will be localized hyperspace boundary engineering and not some trite global hyperspace boundary division as done with SVM. That's my talk. You can get more information on this. This appeared at TSE in 2021. Thank you for your time.
Yeah, thank you very much
Thank you very much
for the nice
for
talk.
the nice talk.
So,
So,
we have
we
one
have
quick
one quick
question
question
from the audience.
from the audience.
No, then maybe we
No,
can
then maybe we
the
can
next talk.
next talk.
So our
So our
second
second
talk
talk
is
is the
in
in
IDE code
IDE code
generation
generation
from the natural
from the
language,
natural language.
promise and
Promise and
challenges.
challenges.
I'm not sure whether
I'm not
the
sure whether
speaker
the
is
speaker
here.
is here.
Yeah, Tim, could you try to? Yeah, I think that's good. Okay, thank you. I'm not sure whether our second speaker is here. Okay, if no, maybe we can skip and to the third talk. Is dependency tracking for risk mitigation in machine learning systems. I think Sherry will present this paper, right? Okay.
Yes, can you hear me okay? I'm
Yes.
sharing my slides.
Okay, great.
Can you see the slides?
Yes, perfect.
Let me start from beginning. Okay. Hello, everyone. My name is Sherry. I'm a senior research research scientist at Cyro Data CC1. The title of our paper is Dependency Tracking for Risk Mitigation in Machine Learning Systems. Other than myself, other authors include my colleagues, Chen, Jeff, Qinghua, and Li Ming. The problem we try to target in this paper is the data-dependent behavior of machine learning systems that may cause the risks. Dealing with such risks in the development phase needs non-trivial cost. So it's continuous monitoring and validation at runtime is a more realistic and cost-effective way for machine learning systems. However, there is still a gap between the model algorithm level solutions and uncertainty handling at the operational level. So in this short paper, we propose a risk management system for machine learning systems that cover machine learning pipeline at both development phase and the systems that use the generated model at operation stage. The objectives of this paper include, firstly, to manage the complex relationship between the dataset models, the prediction, and the associated explanations. Secondly, is to support immutability, as there are multiple parties that involved in at operation time. And lastly, to identify uncertainties by tracking explanation consistency. Here is an overview of the architecture we proposed in the paper. For the data management, the raw data sets are contributed by multiple stakeholders. There is a dataset registry that maintain a list of all the datasets and easier for people to discover and access the raw datasets. Oh, sorry. And there is a so it's also critical to use a version control tool to track the evolution of the datasets. The model management perspective is similar to the dataset management, where we use a model registry to maintain a list of existing models. The model with large size can be stored in a separate model database. And similarly, we need a version control tool like a GitHub to maintain the source code of the models. As query management, we capture the dependency between query or prediction models and the datasets, so that we kind of provide a monitoring mechanism for the model performance degradation, which is triggered by the queries from the end users of this of machine learning systems. The parties who submit queries to the to the prediction model may got different answers from different time. Any change to the underlying data set could cause this inconsistency. And we use a blockchain to provide a mutual and public and immutable data infrastructure to store the provenance data that capture these dependencies. And we use a graph database to store the provenance data. A provenance injector is used to monitor the events of the provenance data being added to the blockchain. And whenever the provenance data is updated on blockchain, the graph database is updated accordingly. Conclusion is that our paper target the risks due to the data-driven nature of machine learning systems. Those risks are difficult to mitigate in the development time alone. So in our short paper, we propose a dependency tracking system, which is aimed to manage the risk across development time and operation time for machine learning systems. And we also try to achieve transparency and explainability through using a blockchain as a public accessible data infrastructure to store the provenance data that capture the relationship, capture the dependencies among model database and data sets and the provenance and the predictions. Thank you.
Okay, yeah, thank you, Sherry, for the nice presentation. Yeah, due to the time, maybe we move to the next talk. So our next speaker is Will. So he will speak about the strategies for reuse and sharing among data scientists in software teams. Sorry. Will, could you try to share your screen?
Yeah, thank you. Hold on, sorry, I'm trying to get it to work. Was working yesterday and now it's not liking me to share the screen.
Could you try to like just some settings in the browser or?
Let me see, it's saying failed to publish screen.
I saw recently.
Go ahead, Tim. Did you have a rec?
I had a pathetic joke about dancing your PhD.
Maybe you could skip me and I'll quit and come back in, and then maybe it'll work the next time.
Okay. So maybe let's first move to the next. And we come back when the settings done. Okay. So will be a universal data augmentation approach for fault localization. Yeah. So I think our speaker will be Jiren, right?
No, I'm still a volunteer. I don't think I'm the speaker for the paper.
Okay.
I'm the speaker.
Okay. Yeah. Sorry. Yeah. Juan, could you start to share your screen?
Okay. Let me share my screen. Okay. Can you see my screen?
Yes.
Okay. It's really a good honor to be here to introduce our work. Today, I'm going to share our work, a universal data augmentation approach for fault localization. Software bugs are prevalent in modern software systems, and software debugging requires a significant level of time for developers. To reduce the cost, researchers have proposed various photolocalization techniques during the past several decades. Photolocalization techniques provide automated ways of assisting developers in locating buggy lines. There are two kinds of classical photolocalization techniques. They are spectrum-based photolocalization and deep learning-based photolocalization. The general pipeline and the DLFL techniques is shown as follows. The raw data are collected from runtime information when the buggy program is executing the test case in the test suite. Spectrum-based photolocalization techniques use formulas, and deep learning photolocalizations use neural networks to evaluate the suspiciousness of each program entity. From the above pipeline, we can observe that the effectiveness of SFL and the DLFL heavily relies on the quality of the input raw data. But the quality of the raw data poses severe threats due to the class imbalance test suite in real-world programs. First, the falling test cases only takes up a small proportion of all test cases, which means we face a built-in class imbalance problem in the real-world test suite. Second, real-world programs are large in size, but only several lines of code or even one statement is responsible for program failure, which makes it harder to capture the buggy lines. So the effectiveness of many SFL and DLFL techniques are limited by the quality of the input raw data. So we propose a data augmentation approach, ENIAC, which generates synthesized falling test cases from reduced feature space for more precise photolocalization. Our approach focuses on the raw data rather than the test suite, rather than the test cases in the original test suite or the photolocalization algorithms. Our approach includes two stages, namely dimensionality reduction and data synthesis. The first stage is dimensionality reduction, which takes the raw data as input, filters out the potential bug irrelevant statements, and then outputs reduced data. For this purpose, we use feature selection algorithm. The following data synthesis stage will construct a generative model for the program. After the model is well trained, it can generate data until the class is balanced. That is, the number of falling test cases is equal to that of passing test cases. In detail, we use conditional variational autoencoder for data synthesis. The data synthesis stage has two main steps, the training step and the generating step. For the training step, the conditional variational autoencoder model combines the input data and the latent variables with labels. The decoder part of the model, and the conditional vector is set to 1, representing the falling test case. Therefore, we can synthesize falling test cases until the class suite is class balanced. Finally, ENIAC takes training data and generated data as a whole for the next F photolocalization techniques. Or the DLFL. In summary, we propose a data augmentation approach, ENIAC, for photolocalization. The key ideas of ENIAC are treating coverage metrics and failure vector as samples and labels, and reformulating the test cases generation problem as a data augmentation problem, and tackling the high-dimensional and class imbalance problem by feature selection and data synthesis. And we implemented our idea and evaluate ENIAC on real-world data sets. That's all for my presentation. Thanks.
Okay, thanks, Juan, for the nice presentation. Will, could you try to share the slide again?
Yeah, you want me to try sharing again? Maybe I won't turn my camera on and see if I don't know if my internet connection is.
Okay. Or if still does not work, maybe you can. Oh, okay, now it works.
Cool. I think it's
Cool.
sharing now. Thank you guys. Sorry for the technical issues, part of virtual presentations, right? My name is Will. I'll be presenting our paper today on strategies for use and sharing among data scientists and software teams. So in recent years, we've seen the explosion of data science, right? It's this very highly iterative exploratory practice, and the tool of choice here has really become computational notebooks. And so I'm showing one in the bottom right here, where you write code and you see the outputs immediately below. However, these have some issues. They can often be messy and non-reproducible. They might lead to bad coding practices, and their users tend to think less about the future use of their code. And we think that all of these issues compound to make actually sharing, reusing, and finding past analyses very difficult in data science. And reuse is really the standard in software engineering, where modular reusable code has been a staple of effective software engineering for decades at this point. There's a variety of rich online repositories to actually help share and reuse code for whether it's JavaScript, Python, or R. And prior research has really shown the benefits of reusing code. So that brings us to our research question today on how does this exploratory practice of data science fit with the fundamental task of finding, reusing, and sharing past analysis work? So to answer this question, we actually did a qualitative study where we did interviews and a follow-up survey with data scientists at Microsoft to understand what are the strategies that they're using to actually reuse past work, and what are some of the difficulties that they encounter. This led us to three main areas of themes, some comments on data science workflows, some strategies that we identified, and then influencers. For the short talk today, I'm really just going to focus in on a couple of these strategies for use and sharing. So I've organized these from what we think take the least effort to actually share and reuse past analysis code to the most effort. And so the first two are just sharing at the personal level. And so it might just be personal analysis reuse. It's just me finding past analysis code that I think is relevant and copy and pasting it into my current environment. This could be everything from just a snippet of code to like a whole analysis that I want to tweak. But it's not actually stored, it's not cleaned up, so it takes very little effort. Whereas personal utility libraries are cleaned up a bit, so take more effort. And then the last strategies, 3, 4, and 5, are actually sharing among a team. And so there's, of course, more just inherent difficulties and complexity in sharing among a team. The third is team shared analysis code, which are just online, often Git hosted places to share analysis code, but it's not necessarily organized into a library like 4 or 5. So I'm going to dive into strategies 4 and 5 a little bit more in depth. For the team shared template notebooks, we think this one was pretty unique and something that perhaps people aren't as familiar with, where these are clean, generalized notebooks for a task and been shared to a central store. So these might be template notebooks with to-dos at the top, or using notebooks as functions and libraries, where one notebook on the left is calling the notebook on the right. This is an example of data scientists adapting an experiment-based tool, the computational notebook, to support more traditional function calls and reuse. This reuse can happen on the platform where their work is done, in this case, the notebook. So this is really important, meeting people where they work. As one of our participants said, these simple notebooks, when the code requires customization when applied to different scenarios, which is very common in data science. Of course, the drawback here is that it can be hard to maintain updates across a lot of notebook forks and tweaks. This is distinct from more of what you might think of as the traditional form of reuse of the library, which of course has benefits like modularity, easy versioning, and updates. But some people, when sharing and reusing data analysis code, really prefer the easy customization and debugging afforded by simple notebooks. So we just do a key takeaway here that the nature of data science work doesn't always lend itself to traditional libraries for analysis code. So I'm going to talk a little bit about some of the influences here. And one of these is that team culture must really incentivize the time investment necessary to share this analysis code. As one of our participants said, sharing code in data science is often not rewarded at the level needed to offset the investment necessary to do it well. So this brings us to some of what we view as the implications of this work for future tool building. So the first is that the outcome of data science is not analysis code. Instead, it's the slide decks that are produced from this analysis, the reports, or the models that are being shared. So it's not actually the code necessarily that's being shared that goes behind these things. But we think that future tools might support a tighter coupling between presentation environments and the coding environments to support a faster analysis iteration. Next is that customization is absolutely essential for reuse. So if I have a template on the left, which is like a model training template, if I use this in 3 different analyses, I might only use some of the steps, I might add in extra steps and remix them. So we think this is partly why template notebooks are such an interesting and powerful idea that data scientists are already using, because it really allows this tweaking out of the box. And lastly, a lack of tool interoperability can limit reuse. So if I have analyses in Python, SQL, and R, it might be hard to actually reuse these in a different environment. And so future tools might try to help address this. So this has been strategies for use and sharing among data science and software teams. I'd encourage you to either scan the QR code or go to that link if you'd like to see our full paper, the 20-minute talk or more. Thank you so much.
Okay, thank you, Will, for the nice presentation. So I think I'm not sure whether our next paper authors is here. Explanation guided fairness testing through genetic algorithm. Is the author here?
Hello, I'm here.
Okay. Hi. Hi, Wenyi. So could you start the presentation?
Okay, let me share my screen.
Okay, great.
So can you see my slides?
Yes.
Okay. Let me start. Good morning, everyone. My name is Wei Wenyi. I'm from Xi'an Jiaotong University. Today, I'm going to talk about our recent work, explanation-guided fairness testing through genetic algorithm. Many research work found that the current machine learning model suffers from the biased behaviors. Some typical approaches try to solve this problem according to testing. Specifically, fairness testing methods try to search for discriminatory samples, and then they improve the model fairness according to retraining. There are 5 typical fairness testing methods. They basically achieved the good performance, but they still have 3 main limitations. First is the low efficiency. For example, when handling the complex deep learning models, SG is very time-consuming because it employs the symbolic execution to generate the particular test case. The second is the low effectiveness. These 3 methods employ the unguided or semi-guided strategies to generate the test sample, so they have a low success rate. The last is the model specificity. Like ADF requires the gradient information to guide the search, so it is invalid for some traditional machine learning models, such as SVM or random forest. So motivated by these limitations, we propose a lightweight model-agnostic fairness testing approach called ExpertGA. It can identify the individual discriminatory samples for both tabular data and text data. Let me first talk about the problem definition. In this work, we mainly cares about the individual fairness. Look at the left-hand picture. These 2 samples have the total same feature values except for the protected attribute sex, but they have the different label. So these 2 samples are regarded as a pair of discriminatory sample. For text data, it is the same. This is the overview of our method. We take the training data set and model as the input, and our method mainly contains 2 phases. In the initialization phase, our method employs an interpretable method to search for seed samples, and using seeds as inputs. The optimization phase employs the genetic algorithm to efficiently generate a large number of discriminatory samples for retraining. Specifically, in initialization phase, we first pre-processing the data. Unlike the tabular data, for text data, they don't have a certain feature set. So we constructed a knowledge graph to match the words with its related features. Once we identify the sensitive words, we generate explanations for the example and get the importance score. If sensitive words have a high importance in classification, this means they tend to be a discriminatory sample. So we collect these samples as the seeds. In the optimization phase, we use seed samples to construct the initial population for genetic algorithm. Then we take crossover and mutation to generate more varieties, expand the search space. Finally, we select high-quality samples to generate the next population by this fitness function. To evaluate the performance of our method, we proposed three research questions. The first question is to evaluate the performance of our method on tabular data. In this table, DSS means the average consumed time to generate an individual discriminatory sample, and SUR is the success rate. We can see that our method have the best performance among these two methods. It takes only, for example, for the first data set, it takes only 0.03 seconds to generate a discriminatory sample. The second question is to evaluate our method or text data. From these two tables, we can see our method has to spend more time on text data because it is more complex. But compared with the baseline method, our method still improved the efficiency and the success rate significantly. The last question is to evaluate the fairness improvement after the retraining. We take a part of our generated discriminatory sample for retraining, and the left are used to test the retrained model. We can see that after retraining, more than 97% of the original discriminatory sample are unbiased anymore, and it takes more time to generate new discriminatory samples for retrained model. That means for the retrained model, the fairness have been improved significantly. That's all of my presentation. Thank you for listening.
Okay, yeah, thank you, Wenyi, for the nice talk. Okay, so I think it's now we have all the presenters paper presented. Could all the speakers turn on the camera and get back to the stage? And yeah, we go to the discussion session. Yeah.
Lei, I guess I received email from the second author.
Yeah.
He said he can't be here in person, but maybe we can play his video.
Okay, yeah, I didn't find the paper have that video on the website.
Oh,
Can
I
you
can
see
play
it?
it. I can play
Okay,
it.
sure.
Yeah. Wait a second.
Okay. 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 Yeah, I also see the email just now. Okay.
Let me share my screen. Mm-hmm.
Does it work on?
No, I guess I met the same issues. I cannot share the screen.
Okay, yeah. So let me try this, but I'm not sure whether it will work somehow either. Let me try quickly. If I cannot do it, maybe we can share the link with the audience.
Okay.
Okay, all right. So luckily, I tried to download this. Yeah, let me see. Where it works. Oh, yeah. I also have the same issue here.
Okay, so maybe we can escape and
Yeah, but
I'll-
let me paste the link of the author's talk in a chat box. So if you are interested in this second paper, please try to see it on the link. Yeah. Okay. Then maybe let's go to the discussion session. So if you have any questions, just please either paste it in the chat box, or you can directly turn on your microphone to ask the authors. All right, so maybe let's start with the first question. I think it's from Roman. So this goes to the question for Will. So just wondering about the modularity of a Jupyter Notebook. Do we need, for example, a new programming language design or a different programming practice for notebook to make it better modular in a way?
Yeah, this is a great question. I posted a short response in the chat. I'd be happy to expand a little bit further. So I think the interesting thing that we noticed is that it's very strange even to think about a computational notebook as being modular and like function based, right? Like I think it's typically like you can have this mix of code. And so the thing that we observed most with the data scientists we talked to was more adapting their programming practices. So one of these was having basically one function per notebook. And so then if I call that notebook, and not every platform actually supports this sort of like calling a notebook as a function. So one in particular is like Databricks, which is a enterprise software like analytics tool. They let you call other notebooks more as a function. So people really like that functionality, but if you don't have that in another tool, then of course you can't do that. And so people would adapt their programming practices, but I think that more like different programming languages or different tools to actually help you reuse a notebook, reuse components of that notebook, reuse it in a more modular ways is a really interesting area of future research.
Okay, yeah, thank you. I think Tim has a question for Weiying. So in our text data set, we are staying with traditional protected attributes like age, gender, or did your system new attributes?
Okay. That's a good question. Sorry, I can hear the echo from my earphone. That's good. Actually, in our paper, we still follow the traditional protected attributes in text data set, but we do find some other interesting protected attributes like maybe sometimes you mutate the feature like location, you can still find the discriminatory samples, but we can't but we can't sure if this bias comes from this attribute like a location, or it comes from its related feature, because sometimes the bias will comes from the related attributes. So we will leave this problem in our future work. Thank you for your question.
Okay, yeah, thank you. Okay, so actually, I have some questions for actually each talk I think is really interesting. So maybe I'll start with Tim. So I think you pick a really interesting question, that the defect in software is really a well-represented imbalance case in the software engineering community. So, but actually, I think data imbalance also occur in other contexts. So, Tim, what do you think will be the unique challenge for these like defect prediction or the SE researchers facing different from other domains like image or NLP?
Well, one thing I keep trying to, I know I'm echoing, I'm so sorry. One thing I keep trying to tell people is that some of the deep learning methods are excessively powerful. You say challenges, I say opportunities. We keep finding that incredibly small feature sets, incredibly small label sets are enough to produce predictions for very large, complex, seemingly large, complex systems, suggesting that there is an undiscovered, unarticulated, simpler machine underneath all our work. I invite you to consider Jim Whitehead's statements on power laws in software engineering from MSR 2015, Prem Devendu's statements on naturalness, the Big Fuzz people, when they did all their pathways, they found systems have incredibly small number of pathways and they could produce tiny test sets even when that code was producing very, very large data sets. I submit to this community that we're rushing to complexity before taking on board the lessons of simplicity. So my biggest challenge I'm seeing right now is an excess of modeling.
Oh, yeah.
Yeah. And I would ask people doing feature selection and explanation to consider what happens if they reverse their premise and say, we will reduce the CPU and memory and time required. ASC 2021, we achieved very good results in multiple domains using 2.5% of the labels and semi-supervised learning. There is a direction towards complexity and there is a direction towards simplicity, and both are worth exploring in software engineering. And I fear one is being overexplored and one is being ignored.
Okay, yeah. Thank you for the insight for us. I also found that there is a recent trend that transfer from model-centric to data-centric in recent days. And yeah, as Tim mentioned, I think this is also a really interesting, important direction. Okay. Yeah, I think we have a question from Tatsu. So his question is for Juan. So if we use the augmented failing test for fault localization, it seems that the total execution time might be increased comparing to SF. So did you try to compare the performance between your Elephant approach with the existing ones?
Yeah, that's a good question. Honestly, the use of the machine learning approach, such as generative model, is time consuming. So in our work, we just find a way to for the data augmentation in the fault localization. We just find a way that can work. The time is more than traditional SFL. Yeah, that's we will analyze the time consuming, compare the traditional spectrum-based fertilization. Yeah, that's my answer. Thank you.
Okay, yeah, thank you for the feedback. And okay, so yeah, Tim, fine. Interesting one. So I have another question actually for our second speaker, Sherry. So I think this is a really interesting work to an important one to think about how to manage the risk between the among all the phases of development phase and also the operational phase. But could you give more a bit of discussion on how your tool or framework can support this whole process. Does it work in a way that's like a platform that can do all the monitoring and these and also the risk assessment at this runtime, or is it kind of you work what way that it can help the user to
Sure.
yeah, for this?
Yeah, thank you for the question. I guess we provide a like a lazy way to monitor the model performance degradation, which we don't plan to continuously monitoring the model itself, but we well, our our approach is triggered by the queries from the end users when they find that the prediction answer, the prediction result is different from a prediction result previously when the end user query the same prediction model. So I guess that's the main difference between the architecture we propose with other existing monitoring mechanisms used in runtime of machine learning systems.
Okay, yeah.
And we also
yeah, by the way, you also use the blockchain in your in the part. Is there a particular reason that the blockchain is used? Does it cause some overhead, for example?
Depends on what kind of blockchain platform we will use. We plan to use a private blockchain. I mean, we will plan to use proof of work type of blockchain, which will cause performance overhead.
Okay, yeah. Thank you for the for answering the question. So I think we have another question from Masood. So the question is for Tim. So performance improvement and the interpretability of machine learning models. So it's both are, for example, desirable properties. So DL is chosen the performance. So is there any like a silver bullet that can achieve both? I think this is a question. So we have these dimensions: model, data set. Should we focus more on data set or model calibration? What are missing?
I deny the premise of the question. I think for certain domains, it's clear that you want to do the deep learning. When Prem Devenbu tells me that his deep learners are the best translation devices he has between code and human English, I completely believe him, and I think we should do deep learning for that task. For many other tasks, the benefits of deep learning are not so strong. No one is seriously benchmarking in software engineering the deep learning versus non-deep learning methods. And also, I deny the dichotomy between the two. My PhD thesis was on applications of abduction. Abduction is the logic of explanation. I submit to you my entire career has been the optimization of both performance and explanation. I submit that if we know more about the algorithms, we can explain better. And if we know more explanation, we can run the algorithms better. And if you look at all the recent papers from my research group, we've optimized both explanation and performance. So I think, my answer is, why not both?
Okay, thank you, Tim. Okay, so do we have some questions from our audience? Yeah, so yeah, I have some questions for Will. I also think this is a really interesting work. I'm wondering, actually, for example, have you considered how concretely we can, for example, facilitate the code reuse and the sharing, especially in a big group? Because I know some cases, some companies are trying very hard to reuse the legitimate data or code. For example, they have a big source code repository in the past, for example, 20, 30 years. like using code engine, search engine, something like this. Do you, for the data scientists in the context you consider, do you have some suggestions how, for example, a team or group can think about reusing this mechanism tools, for example?
Yeah, thank you. That's a great question. I think it was interesting. I think mostly in our paper we attempted to basically describe some of the strategies that people are using today, and then I think there's kind of still this open question to us about, okay, which of these is better? Because I feel like so our study was specific to Microsoft, but I think that these insights, you know, apply to other groups as well. But we found that like there really is no, like each group kind of finds a way to reuse in their code among the different data scientists on the team. So some of this is very formal, where like they have a GitHub where each person, or maybe each data source, because if you think about it, all analysis code is tied to a data set as well. It's not just the code on its own, but you need code and the data together. So either organizing it by the data set or by the person that wrote that code. And so I think that's why I'm excited about one of the kind of implications that I talked about. If we could have a tighter coupling between, if I'm showing you a presentation of the analysis that I did, and you can somehow go and find the notebook that I was using to produce the charts or to produce the model, I think that could be exciting, because then you don't have to go searching through all this other analysis code. So I think that it's definitely something that data scientists want, is to be able to share and reuse their own and their teammates' code. And then there's, I think, a variety of like different levels of maturity, if you will, and like how complex their solution is to that problem. Hopefully that answered your question.
Okay, yeah, thank you. A very quick one is that I see you perform some study on the interview from the from the data scientists with different experience group. For example, as you mentioned, from 3 months to more than 30 years. So did you find who will benefit the most with the reusing code and in some particular way? For example, I'm not sure. Yeah.
Yeah, I think that we found that the more experience someone had, basically the better they were at reusing their code, right? If they've been doing data science for 30 years, like when they see a new analysis request, or they're like, hey, can you answer this question? Like, oh yeah, I've done this dozens of times before. So they have like this better like mental structure about how can they find their past work. But I think that I think that they're faster at it, perhaps better at reusing, but I think it really benefits people that are new when they come onto a new team, and like, how do I like do this analysis? There's got to be some other work, and how to actually find it. Yeah, I self-described data science for 30 years. I think they probably called it statistics, and then they've readapted.
Okay. Yeah, thank you. Okay. Yeah, we have a quick question from Ting. I think it's to Sherry. So she was wondering if any potential future work could be done around this dependency work direction.
Future work.
Or concerns.
One concern is the scalability of the graph database, I guess. How much data set, how many queries we can support at runtime use the graph database. Because currently the scenario we use is a food supply chain where people so this is a collaboration with our architecture department, where the scenario is that the consumer of a data of a beef product can query the prediction model to check the originality of the beef, whether it's come from a farm in SW state or come from a Queensland state. And we find that over the time, there, especially when there are more data points that are collected, like on the boundary of these two states, some of the beef product previously classified in, for example, SW farm may later change to Queensland farm. The originality the originality of the beef product may change over the time. So that's why That's the main motivation for this work. But currently, the data set we use are pretty not a sizable data set, I guess. So scalability may definitely be something we can work on as future work, I guess.
Okay, yeah, thank you, Sherry.
Thank you.
Okay, so I have some questions for Juan. So I think in your work, the conditional VAE is a really important component. But usually, how do you think you can, for example, in your case or your experience in making this CAVE works in your case, what do you think the important points, for example, to make it work, or is there a way to assess its quality in terms of how it plays in your whole pipeline?
Okay. That's a good question. And for the CVE model, it is a model that can learn the underlying probability of the original data, and the original data is what we use is coverage information and the test results. For the recent years, there are many deep learning based photo localization techniques that can do better than traditional SFL, which means within the coverage metrics, there are distinguished features that can make a distinction clearly, which is responsible for the program failure. From motivate deep learning based photo localization.
Okay.
We think the lambda underlying distributions. So and our can also prove this. That's all for my explanations. Thank you.
Okay, yeah, thank you, Juan. Yeah, so I think we have limited left, and yeah, we have another question for Juan. So this data augmentation for the failing test cases, did you also get the chance to take a look at, and how accurate they are? Do they look like human written code? So yeah, that means yeah, whether you look at the generated test cases, whether they look like real ones or it's just like obvious machine generated ones.
Okay, the generated samples, we can the generated size samples is just like the machine generated, and in the real world, there may be lots of coverage paths that there may be or not. There may not have the test case that have the same coverage path. So so the generated just capture the features, the key features of falling test cases. Yeah.
Okay. Thank you, Juan. So yeah, I think this will automatically turn off when the time runs up. So let me ask a last question, and maybe in the middle of answering this question, the stage might cut off. Yeah, but let me try this. So yeah, I have a question for Weiying. So I think you mostly focus on the individual fairness, but have you also considered to adapt your method to the group fairness as well? Yeah, you mute your microphone. Let me try to.
Sorry. Yeah. We have considered to expand our method to the group fairness, and I think we will continue this in our future work. Actually, this year there is a paper in FSE 2020